Bismillahirrahmanirrahim. Assalamu alaikum. So today we will go on to the next topic. I have talked about encompassing as a crucial, as a necessary ingredient which is required for validation, which, sad to say, nobody understands, even though it is. You cannot get a valid result without understanding this. If you just run some collection of variables on something else and declare that this is the effect of x on y, this is just wrong, because x is just one in a whole range of variables which are potential effectors. Currently, actually I asked this question at the interviews which he had for Econometrics recently, and somebody who is right now making a lot of noise about not having been selected failed to answer not just this question but every single question on Econometrics that I asked him. So the question is this, that actually we covered this last time, that people think, I'm trying to explain what the error is, that if I want to know what is the effect of health on GNP, I run a regression of health on GNP. If I want to find the effect of IPR on GDP, I run a regression of that. And if I want to find the effect of FDI on GNP, then I run. This is all completely wrong, because what people don't realize is that if somebody runs health on GNP and gets results, and the other person runs IPR on GNP and gets results, these two are in conflict. This conflict is not understood. People say, yes, I've got the health variables, and the other person says, I've got the IPR, and both are right. This is wrong. Both cannot be right. Because if the health equation doesn't have IPR, then the health equation is saying that IPR does not affect GDP simultaneously with saying that health affects. And this is in contradiction with the other guy who is saying that health does not affect GNP, even though this claim is nowhere written explicitly, but this claim is being made. When you say that I have got this is what the axiom of correct specification is about, that you have got the right regressors. If you don't have the right regressors, then your result is invalid to begin with. So this conflict is not understood by practitioners. They say, okay, I can write about health and I can write about IPR, and everybody is happy because we get 3 articles. So the way to do that is to use encompassing, and encompassing means involving all of the variables. Now, people asked correctly last time that this is impossible, that we can never have all the right variables. So actually it is true, it is impossible. So what one needs to do is to look at major determinants. So what are the major determinants? Like in the case of consumption, it turns out that the GNP is the big influence. The income is the big variable which matters. So if you put that in and you miss minor variables, it will cause a bias, but it will be minor. So that's one answer. The second answer is that if you take into account all variables which are available to you, so all the data there are variables which are either unobservable or they are observable but you don't have data about them. So there is no chance to use those variables, so you can omit those variables. Now then, if you are omitting a major variable, that will cause serious problems. But if you are omitting a minor variable, then to some extent you can understand how omitting that variable would affect the results and make qualitative adjustments. And this is what good practitioners of econometrics do. They say that we have this variable probably matters. I don't have any measurements on it, so I will run this regression, and I know that omitting this variable has caused a bias, and I can estimate what that bias will be, because we know the rules for calculating the bias. If I have some idea of which is the missing variable and what it is correlated with, then I can calculate this bias. So there are these pragmatic rules, these practical rules which you can use if you start from the right place. So that is a second answer. Then there is a third answer, which involves a more complicated model. Then you have to go beyond regression models. So we won't get to that one very soon. I'll try to get to some answers which we can produce, how we can just change the methodology and go into a different methodology which can take into account some of these things and work with limited knowledge. I mean, we don't have to know everything in order to be able to study something. So, and this is the intuition that if I want to find the effect of health on GDP, then I only need to look at these variables. There is an intuition there, and so I don't need to worry about the remaining variables. And what encompassing says is that that's not right. Now today I'm going to do something which is exactly like that, which is I'm going to look at two variables at a time. So now this seems to be in contradiction. Uzma, तुमने वो slides बनाई थी last time? नहीं उज़मा वो उज़मा दूसरी उज़मा बशीर. ओह सॉरी मारिया. अच्छा उज़मा बशीर नहीं आई है, मैं कंफ्यूज हो गया मैं. ठीक है वो भी राइट. तो वो स्लाइड्स उसके नहीं है, उसने बनाई थी, अब मेरे पास उसकी पूरी थीसिस है. एनीवे व्हाट वी आर गोइंग टू डू इज टू लुक एट टू वेरिएबल्स एट अ टाइम. And I have just told you that that's the wrong procedure. So now we have to understand that there are two types of data analysis, very distinct, very different from each other, and having entirely different meaning and consequences. One is called exploratory data analysis. This is never taught to econometricians, and that is a big mistake. The other type is called confirmatory data analysis, and this is what you are taught in all your courses. You are only taught confirmatory data analysis. So one is called EDA. Tukey is the person, famous statistician who invented this, and he has a book called EDA, Exploratory Data Analysis, and he explains the difference there. So exploratory data analysis is when you are just looking at the data and trying to understand what the data is trying to tell you without having any preconceptions in your mind. So you're just exploring what are the patterns in the data and what can we learn from this. Confirmatory data analysis happens when you already have a hypothesis that is in your mind, and now you want to use the data to confirm or to disconfirm this hypothesis. So I already know in advance, because of theory, that there is a Keynesian consumption function. Now I want to use my data to just fit the function, for example. There's no issue of testing whether or not consumption is determined by GDP. I assume that from the start, and I formulate my equation as C equals alpha plus beta y. I don't formulate it as maybe y equals a plus b c or the other way around, and I have to decide. Now if that was the question, that I don't know which direction the causality runs, then this can also be answered, but not by the techniques that any of you know at this time. This is not because this is a causal question, and causal questions cannot be handled by techniques which are taught in econometrics textbooks currently. Although they can be handled, and there are techniques, but econometricians don't know of them. So, but it is true that causal questions are very difficult, and there are no standard put it into the computer and find out the answer methods. You have to use your brains. It's called shoe leather, actually. We discussed this sometime. So anyway, the point is that econometrics is all about confirmatory data analysis. You start with the hypothesis, and then you test whether this hypothesis is true or whether it's false. Now, when we look at variables in pairs, this is only to explore what the data tells us about the relationship. And so, after looking at these, then we might generate some hypothesis. And once we have a hypothesis, then we can go on to the second stage, which would be that, okay, you take the hypothesis and you estimate it, and you find out how well it fits, and so on. So there was this thesis of Uzma on determinants of corporate philanthropy, and what she did was, so today we are going to just look at some problems that arise in exploratory data analysis. And basically what I'm trying to teach here is how to look at the data and to understand what it is telling us. And let me say that initially I didn't take a lot of interest in this. So what Uzma did was, first she collected all of the annual reports from the companies listed in the Karachi Stock Exchange, and then she input the data. That was quite a task. And then she collected, did a literature review of the corporate philanthropy and the variables which are supposed to affect it. So she found that, for example, here's the list. In the literature says that firm size is a determinant of corporate philanthropy, and basically the hypothesis is that the larger the firm, the more they will give. Firm visibility is also related to corporate philanthropy. Labor intensity, all of these are just names. I forgot what the literature says, but basically in the literature there are hypotheses about how this variable affects. So this is one thing that you need to do, is to look at the variables. Now the encompassing analysis would require that you create a big regression with all of these variables, and then you reduce. But and that's what was done eventually. But before we do that, we do a preliminary exploratory data analysis to see what the data is telling us. This is very important. So let's see now. So what I was going to say was that what happened was that first she did this whole thing using regressions, and she came up with results which were very puzzling. And so then I said, okay, go back and plot the data and bring me the data plots. And then when we looked at the data plots, then we found that all of the regressions were basically wrong because of factors that I would like to show you. That why is the regression wrong? That's what I want you to just be able to do, to look at the data and say what the regression will look like and why this is wrong. And the sad thing is that nobody does this. We get through so many submissions where people are claiming this and that using regression model, but nobody has ever bothered to plot the data and to see. So here, this was a practical example where regressions was done, and then after plotting the data, we realized that all of the regressions are wrong. And so I'm just going to show you how this happens. I think I would like to do this. Okay, this is first graph. So basically, I want to look at pictures this day. So here, this is the Pakistan Corporate Philanthropy Report, which shows the level of donations. Now, what can we tell by looking at this picture? This is the overall corporate philanthropy. What does it tell us? Can anybody say? Before I give you a hint, I want to ask. Can anybody tell me something which this picture, which is aggregate level starting from 2000, 2001, 2, 3, 4, 5 and 6 and so on. This is the data on aggregate corporate philanthropy. What is this data telling us? Yes? Take a guess. This is what exploratory data analysis is about.
Overall a positive trend.
Okay, yes, there's a positive trend. That's definitely what the data is telling us. The corporate philanthropy is increasing, but there's something more interesting. Yes, that's right. We see that there is an earthquake, and we see that corporate philanthropy responds to the earthquake. There is no regression, no mathematics. The data tells us by eye that firms respond to need. Is earthquake, is disaster a factor in determining corporate philanthropy? Yes. I don't need to run any regressions. I know the answer already. In fact, people have run regressions to assess this, but that's Mickey Mouse. It's meaningless. You can't get that information from running regressions. You can get it by looking at this picture. Here's another picture. I don't know what that is, so I'll skip it. Okay, so this is the literature review, which is basically going through all of the variables and setting up your null hypotheses about the association based on what the literature says. Basically, from the encompassing point of view, what this is doing is telling us all of the variables which we need to include in our baseline model. But before we do that, we must start by looking at the exploratory data analysis. That is a crucial step which is missing from standard analysis. So now, first a little bit of theory. This theory is described in my textbook, chapter 5, which is on robust regressions. And I also have a paper on this topic which I wrote with Peter Rousseau, which is very popular. It's one of the, I think it's my most widely cited paper. It is taught in, one of my students told me that he took a training in England and they were teaching this paper. So this paper is very accessible. It's not mathematical, so I would like to recommend that you should read that paper, because I won't be able to cover all of the issues that are described in it here in this lecture. What the paper is talking about is the effect of outliers on regressions. So what the paper says is that there are two types of outliers. One is called a good outlier and the other is called a bad outlier. So here we have a situation where we have a good outlier. The most of the data is on one straight line, and then the outlier is very far away from the data, but it is also on the straight line. So this is a good outlier. It strengthens the basic picture. Then there are situations where you have bad outliers. Here, the regression line is actually of negative slope, but there is one outlier which is the same as the previous one, but it is now not going in the direction of the data. So what will happen? What happens is exactly this blue line is the regression line. So now if somebody runs a regression on this data set, he will say that there is a positive relationship between y and x. As x increases, y increases. It's completely wrong. There is a very strong negative relationship between x and y for normal range of y, but there is one very strong outlier. There are many natural phenomena like this which are listed in Russio's book. So it's not enough to look at outliers. You have to understand what kind of outliers they are. And the second thing, which happened to be the most important thing in this particular thesis, was clusters. Here we have a situation. This is sort of schematic, but something like this was there. Here we have two clusters. In one part of the data set, we have a strong positive relationship. In the other part, there is a strong negative relationship. So there are two clusters of data. In one type of data, there is a strong positive relationship. Let's say that, for example, one is data on males and the other data on females. So if you ignore the gender variable, the blue line will be the fit, which will show that the two variables are slightly positively correlated. But if you split the data into two groups, then you will find that results are completely different. In one half of the data, you have a strong positive, and the other half, you have a strong negative relationship, and the blue line is just completely meaningless. It has no relation to the actual data. So this is also, all of these are situations which actually arose in the data set that we looked at. Here is a situation where in the rectangle there is no relationship. You have to understand, this is something that probably you haven't done before. This is something that I practice with my students quite often, that I show them data and ask what's the relationship. So basically inside a rectangle, if you don't have a relationship, then all the points should be scattered evenly all over the whole rectangle. So it should be uniform. And that's roughly how this data was generated. So it means that if you change x, the pattern on the y-axis is the same. If you change y, the pattern on the x-axis is the same. So there is no relationship between x and y. If you run a correlation, you will find 0. On the other hand, for large x variables, there is a strong positive relationship. So now the correct way to describe this is to say that for values of x up to a certain threshold level, there is no relationship between x and y. But after x exceeds a certain boundary, then x exerts a very strong effect on y. This is what the data is telling us. Now, after looking at this, I can create the model which relates x and y, which is a nonlinear relationship. Y as f of x would be no relation. Y equals for x less than or equal to some threshold value, and then y is a function, a strong linear function of x. But without looking at this relation, if I without looking at the data, if I just run the regression, I will have this blue line, which is the regression line, completely misleading about what is the true relationship. And as I said, this is a real case in the sense that Uzma actually came to me with all of those regressions, and they are all giving very puzzling and contradictory results because none of those regressions had any validity. Here is a similar situation where we have two relationships, and the fitted regression science shows that there is no relationship, when in fact there is a very strong relationship, but one part is a negative and one is a very strong positive, and together they cancel. And in the big picture, it seems like there is no relationship. So the regression tells you that there is no relationship, when in fact there is a very strong relationship, non-linear. Okay, so now we did fixed effects and random effects. You have to fool people into thinking that you can do some technical stuff, even though it's all nonsense. It has no real bearing, but you have to demonstrate to others that you know about conventional econometrics in order to impress them, and to convince them that you have. क्या हुआ? Cluster analysis is a very obscure topic in conventional econometrics, and actually I don't know of anybody who actually knows about it very much. Cluster analysis is another topic which Rousseau has studied. So here is the real data set on firm size and corporate philanthropy. This is what the data looks like, actual. Now, what do we learn from this data? I said if you run a regression, you get a negative relationship. I haven't put the blue line here, but it would show that the higher the firm size, the lower philanthropy. That's what we came, and in fact that's what was puzzling, because this result is contradictory to what the literature says. Can you see that the relationship would be negative? This is one of the skills that you should be able to develop by looking at the data. Tell what the blue line would be. Here the blue line is missing. No, it will not be positive. It will be a negative relationship. I wonder if... Yeah, exactly. It's the outlier which would... Here is one example. This is... So since there was no relationship, we sort of tried to find break it down. So here's the automobile sector, firm size, and here... okay. So here, okay, let's start with this. This is easier to interpret. What does this graph tell us about firm size and corporate philanthropy in the automobile sector? Now, according to the blue line, that's the regression line, there is a mild negative relationship. As the automobile size, as the firm size increases, the larger firms in the automobile sector give slightly less than the smaller firms. But what is the data telling us? Regression line shows there is a weak negative relationship between firm size and CP. What does the data say? What? There is no relation. Exactly. The data says that there is no relation between firm size and CP in the automobile sector, but there is one automobile firm which is quite small and it makes a huge contribution. So now what should we do? This is something which I want to tell you, which is crucial. Now what we need to do, as a result of this exploration, what we should do is we go look at this firm. which is the firm? Is it Suzuki? Is it and what do they do and why are they doing it? So students were in, and I am advocating a new approach to econometrics, and this approach we can call real econometrics, because what is currently being taught is nominal econometrics. You just look at the numbers, you don't look at what is behind the numbers. And I am saying that this is completely bogus. You can never get anywhere by numbers alone, because I can show you situations where exactly the same numbers are generated by entirely different processes. So unless you explore the process which is generating the data, you can never get to the truth. So here, the data points us to what to look for. After looking at this picture, I have this massive data sets with hundreds of firms, and I say, here is this firm. This firm is doing something unusual. Now let us go to the world. Let's expend some shoe leather and find out why this firm is different. And this will lead us to some knowledge which you can't get no matter how many regressions you run and no matter what technique. Now what you have been taught is that, okay, this data set has an outlier, so let's try to fit two-stage least squares to it, or do factor analysis, or do something else. There's some magic tool that you can find which will solve this data problem. That's wrong. I mean, that's not what econometrics is about. Econometrics is about using exploration to find out any unusual pattern, and then find out what in the real world is responsible for generating this unusual pattern. We go back to that. That's more complicated picture. This one. Well, basically, ignore the zeros, which is the bottom line. Then it's a negative relationship, right? Oh, you see, that's the thing, that if you just think of these three dots as three dots, that's what happens when you have clusters, then they have a negative relationship. And that's how the regression line will run. It will not run like that. If you just ignored the red line at the bottom, then that's how it would run. But because of this huge number of zeros, the regression line will be pulled downwards. So it will be a negative relationship, but it will be down close to the axis. It will be influenced by those outliers, but it will not be determined. So now, if we think about what this is telling us, well, there is one outlier. This is the same outlier as before. Then this is probably the automobile, which is very generous. Maybe it's because the boss is a very kind-hearted person. And if so, then we would learn that the corporate philanthropy is determined by the character of the boss and not necessarily by the firm size. And that's something very important to know, because then why are we studying this corporate philanthropy? Because we want to make some changes in the world. We want to have this increase. We want to have more philanthropy. So if we learn from this one person that, okay, look, there are these hundreds of firms of all sizes, nobody is giving anything, but there's this one little firm and they're giving very generously, and the reason is so and so. I don't know what it is. And so now that gives us a very important clue as to what we should do when we want to improve corporate philanthropy. So now here, what is the picture telling us? Now the regression is absolutely misleading, but the picture, what does the picture say? Okay, I've labeled the clusters. One is just a single outlier, a small firm with very high CP, with very high copy. The second is the C2, which is a second cluster. C3 is the third cluster, and the main cluster is around the x-axis. So what do we learn from this data? without doing any regression. Yes. Exactly. For most of the firms, what is true? What? There is no relationship between, that's really the largest number, very large number. There are a few firms which are of large, let's look at so this is what the data is there. For most firms, there is no relationship between firms. That's very clear. We don't, the regression would be misleading. It would say there's a negative relationship, and it would be just wrong. This is a clear conclusion. I don't need to run a regression. I can look at the data and say that there is no relationship between firm size and corporate philanthropy for most of the firms. However, there is a small cluster of firms which are high sized, and they have varying, they are all contributing. So now I would look, again now we go to real econometrics. I would look at what are these firms. First of all, here it's again clear for this cluster that there is no relationship. All of them are of the same size, roughly. But they are giving very different levels of philanthropy. So again, this cluster proves that there is no relationship between firm size and philanthropy. On the other hand, these three firms are different from the rest, and I would go and examine what is the factor that makes these firms different and see if I can find out something. Then there is another cluster, the C2 cluster. In this cluster, there is a fairly strong positive relationship. As the firm size increases, the firm size varies over a very narrow range, and there is a very strong response. The smallest firm in this group is giving very little, and the biggest firm is giving a lot. So, what is special about this firm? Again, we have to do real econometrics. There is no fancy technique that we can apply to this data that will reveal the answer to us. We have to go in. Yes? Excuse me? Yeah, you can, but there is no need to. I mean, what will the regression tell you more than what you can see? The regression, anything that the regression tells you that is more that you can see is an illusion, in the sense that it is based on the assumptions that you add on top of the real data. So, there is no need to run regression except to fool other people into thinking that you are an econometrician. Yes. Yes.
So from looking at all the methodology, it looks very simple and very powerful indeed. But what's the reason that it's not that widely accepted as econometrics is? Is it because econometrics involves a lot of sophisticated mathematics and all that stuff, so that it can pose as real knowledge as opposed to exploratory data analysis?
This is a very good question. It has to do with history of thought, how some ideas become powerful and how others don't. And it's both of these things. Actually, it's sort of an accident of history. I was explaining this earlier to another group. That what happened when statistics got started in the early 20th century was that computation facilities were not available. If you had a data set of 1,000 points, you could not plot it. There was no, it would be very painful and cumbersome. So as a result, when econometrics got started, when statistics got started also, what they did was they said, let's make a convenient simplifying assumption. The most powerful convenient simplifying assumption is that of normality. If the data is normally distributed, then you can take 1,000 points and summarize it by 2. Just the mean and the standard deviation, these two are enough for a normal distribution. This was a very powerful result. So, bravo, we can take any large data set and just calculate the mean and SD, and we know about the whole data set. This was a very convenient assumption, and it was not possible to check whether or not the data is normal, and B, if you found out that the data was normal somehow, there was nothing you could do, because the techniques required to handle non-normal data sets did not exist and required high computational equipment which was not available. So now the thing is that this situation has changed, but the textbooks have not. I mean, it's called path dependence. Once you got started out onto the wrong track, and people invested huge amounts of time and money and textbooks after textbooks, and people have spent their lives studying heavy techniques. I spent my life studying very difficult mathematics required to analyze data sets, and people got carried away because basically if you take a data set, if I make this fancy assumption, I can get this result. If I make another fancy assumption, I can get another fancy result. And so this was the job of the theoreticians. We divided up the task, that the applied guy would look at all the theory. I would never look at the data. So, and the applied people would look at the theories and would find the assumptions which match their situation. So we put the responsibility on the applied person to check whether the assumptions are valid. And the applied guy said, well, the theoreticians are saying this, so it must be true. So nobody bothered to check the assumptions. This was literally true. And I was doing my PhD. I went to my advisor, the graduate student advisor, Larry Lau, and I asked him that, well, I want to do econometrics. So he said, well, what kind? There are two people here. There is the people who get their hands dirty, and then there's the theoreticians, Takeshi Amemiya and Ted Anderson. So it was obvious from the way it was said that the prestige belongs to the theoreticians who never get their hands dirty with real data. I mean, that's amazing, but that is the truth. So I never ran a regression on real data until I got to Johns Hopkins, and I think it was Bruce Hamilton who was the chair of the department, and I decided to do an example. I was teaching econometrics on real data for the first time, and I didn't know how to run a regression on real data. I know how to do. I knew how to do it in Gauss using primitive techniques, but direct. Put in the matrix and do X transpose X inverse, but I didn't know how to use a software package which would which people use. So I wanted to show the class. So I went and asked him, and Bruce Hamilton was very happy. He said that I will tell people that I have taught Asad Zaman econometrics. So he taught me how to run a real regression. So anyway, what I was explaining was that there is the split between theory and practice, and the prestige goes to the theoreticians, and the applied people don't. Applied econometrics doesn't count for very much, and unfortunately, it should be the other way around. And because of this split, the people keep making unrealistic assumptions. In fact, David Friedman, who was went through a similar transformation that I have. Initially, he was a very high-powered theoretical statistician. If you look at his papers, they're all mathematics and such heavy mathematics that it's hard to follow. And then eventually, when he started working with real data, he came to the realization that none of the assumptions that we are making match the structure. And it's very easy to see. If you look at the data, like you look at this data set and you say that you can't run a regression on this. I don't need to check assumption 1, 2, 3, 4, 5. I just know from looking at this data that this doesn't satisfy the standard regression conditions. So basically what he found and what I found later, so actually David Friedman wrote this book called Introduction to Statistics, in which there are no formulas, which is really a surprise and a paradox, given that his own strong mathematics. He said that mathematics get in the way of understanding. As soon as the students are drowning and they're looking for a formula, as soon as they find one, they grab onto it and say, okay, I've got the answer, now I've got the formula, now all I need to do is to find the numbers to plug in and I will have the answer. and I only need to think. So he said that, okay, we remove this crutch. There are no formulas in the book, so now you have to read and think. So that was his approach. And when I read that book, then I learned statistics for the first time. That was a long time after graduate school. Oh, this is what real statistics is about. It's not about making up newer theories and doing mathematical calculations. So anyway, so here the data is teaching us what I already said. So now what we do is we have to unstrip. You see, basically the way that the world has been divided is that the theoretician looks at those properties of the data which don't require a name, because he is just looking at data. So which point belongs to which cluster, whether this is automobiles or whether this is railroads, this is something which doesn't concern the econometrician, because the econometrician only looks at the data. And the applied person, he knows about railroads and about automobile industries and so on. So he has the real knowledge. But somehow these two never get together, and so the inference never gets made correctly. So that is why if you want to do econometry, and this is what I have asked all my PhD students who are working in, or MS either, that in addition to running regression, you have to go and study the real world issues regarding whatever it is that you are doing. You have to look at what happened in history, what is the nature of industry in Pakistan, and so on. Real factors, because without knowing the real world context of the data, you cannot understand the data. Okay, let's look at some other cases from this. Here is a very interesting case. This is the chemical stocks. Again, this is firm size and corporate philanthropy within the chemical sector. And what do we see? The blue line gives an entirely false picture that the increasing firm size is leads to a reduction in corporate philanthropy. The picture is very obvious. Here there is a cluster of firms in which there is very strong correlation between size and corporate philanthropy. These are a very small minority of the firms. And then for the vast majority, there is no relationship. And so this is what we get from looking at the picture, which we would never get from any regression analysis. Right side pe? Somehow right side पे the negative relationship होगा. Yes, there's a discrepancy between what I have on my screen and what is showing up there, which I am puzzled by. But anyway, this cluster is positive, clearly. Oh, you mean why the regression is negatively skewed? Oh, that's something that. Oh, yes. Well, that's because if you think of that cluster as just one big outlier, which is lying on top, it is occurring at the early part of the data. So it's going to pull the line up towards itself in the early part. In the lower part, there is no outlier, so that's going to go towards zero. Here is CP and construction. Again, this is similar. Here again, we have a couple of outliers on the right hand side as well, which I haven't pointed out. You see, there are 4 types of outliers. One category that I have already told you about, one is called the good and the bad. So these are both bad outliers. This one, because they don't conform to the basic pattern of the data. But in addition, there is another concept which is high leverage outliers and low leverage, and these are the things which are discussed in my paper, which on robust regression, you should have a look at. So the high leverage outliers actually strongly affect the regression relationship, and the low leverage outliers don't affect so much. So the in this particular picture, the high size outliers have low leverage, and so they don't really cause much damage. But the one big outlier which has low CP, that has a lot of leverage, and so it pulls up the line towards itself. Why this is so? This requires some fairly complex analysis. क्या कहा? Okay, here's the financial sector. Again, middle में जो outliers होते हैं, they don't cause much damage. These are the basically, an outlier has high leverage if it is occurring near the end. Then it will draw the line towards itself. If the outlier is near the center of the data, then it has low leverage and it doesn't cause as much damage. So here there are lots of outliers, but not with much leverage, so the line is not much distorted. It is pulled up a little, but the slope is not distorted. So here what would we do? So the thing to do here, which is what I actually asked Uzma to do, after looking at this, is that you see there are a few firms, very few, which have a large number of, which have high philanthropy. And then most of them have very low levels. So if we divide firms into having, and we put a truncation point at the philanthropy size, and we say, okay, consider all the firms which have philanthropy less than or equal to some cutoff, then on these firms there will be a clear-cut 0. And then there are some which have a relationship between firm size. Then there are some firms which are contributing a lot, but there doesn't seem to be any relationship between size. They are just randomly scattered. So then the issue here becomes, what are these firms which are contributing a lot? There are maybe 5 or 6 of them. So again, real econometrics, you have to expend shoe leather to find the answer. By the time we got around to this, it was so late that deadlines were expiring, so we didn't get to the actual. I did ask her to do some real analysis, but we couldn't really get to that stage. But this is an interesting picture. Again, this is firm size and CP in the miscellaneous sector, and then so there is a strong negative relationship here, unlike the chemicals where there was a small sector which had a strong positive relationship. Here again, most of the firms there is no relationship, but there is a cluster which has a strong negative relationship. Oh, acha, the blue line. No, the clusters are marked out by the dark black line. I know. हाँ, both are. ये तो firm size है, so firm size cannot be negative, and corporate philanthropy also cannot be negative. You mean the blue line is what you're talking about? Yeah, right. The blue line is sort of an average of the a black line and the zero line, and so but the weight is given more to the bigger cluster, and so it is pulled more towards the zero line, and so that's why it's looking like what it is. Here there's again nothing new. There's another interesting pattern here. There is this is between firm visibility and corporate philanthropy. So now there is the blue line is the relationship, which is completely distorted. There is a cluster of firms on sitting near zero, and I think there is also one outlier which has not been pointed out here. It's over here. So this is pulling it down. This has high leverage, and so the correct analysis of this data is that, first of all, get rid of all of these firms which have nearly zero CP. So there is a group of firms in this sector. This is not a sector, this is the whole. So there's a group of firms which are not contributing anything. So get rid of them. I don't know why they don't contribute, but that's something that's worth considering on its own. So if we just restrict our attention to the firms which do have positive philanthropy, then there is a very simple. Now here this black line is a correct regression model, one of those rare cases where regression is actually a useful technique. Here the assumptions of your regression model are satisfied. Still, the blue line is completely off because the zero cluster has been ignored, and this one outlier. So get rid of this one outlier and get rid of this cluster, and now you have a fine regression model, and basically you can say that there is a strong positive, clear relationship between firm visibility and corporate philanthropy. Again, the real issue is, what is the causality? It is very possible that firms which do more philanthropy achieve greater visibility because of this philanthropy. So the relationship runs in the opposite direction to the one that is being postulated. So, and there is another possibility that the firms which seek or strive for visibility, they put out a lot of ads and they do all sorts of things to achieve visibility, and they also do philanthropy to achieve visibility. So there are three different hypotheses. One is that firms which are more visible do philanthropy because they think that they are concerned about their image. So then visibility is the exogenous variable and philanthropy is the endogenous variable. There is the possibility that the reverse is true. Firms which are doing more philanthropy achieve greater visibility as a result of this. And there is a third possibility that the driver of both visibility and philanthropy is another variable which we don't have in the picture. The firm has this desire to achieve visibility, and it does it by all sorts of means. All of these three things are extremely different. They are crucial if you want to do any policy analysis. Then you need to know which of these three is true. There is the right way to do analysis and there is the wrong way which it is done. And so what I was saying was that in order to do policy, suppose that let's ignore the outliers and then let's ignore the zero cluster. So if we were doing the analysis the right way, I would look at the single outlier and study it and see why it is outlier and make up some explanation according to the real world. And then I would say, okay, here's a zero cluster, and it has its own reasons, and let's suppose that I can find some sensible answer. The world is like this, that not every question has an answer and not every answer can be discovered. But let's suppose that this is an easy situation. I find a very good, genuine reason for this outlier and say, okay, this firm, which is the right-hand side high leverage outlier, is contributing less than it normally should according to the regression line because the firm was bought out recently or some other exceptional circumstance which does not apply to the rest of the firm. So I can explain this and I exclude it. Similarly, there is this whole cluster of 100 firms in Sialkot who never contribute anything. Their owners are very conducive. They belong to Banya families and so on. So we exclude those. And now we come to the main sequence. And in this main sequence, we find that our regression analysis is perfect. The line fits perfectly. Assumptions are satisfied. And so now what I'm saying is that in this particular cluster, the most important thing we need to know is the causal sequence, and this causal sequence is something which econometrics will not tell us anything about. So if you run, to give you a very real example, if you run a cross-section panel data on the on the WDI, World Development Indicators data set, you will find a very strong positive relationship that is very stable across time, which is that the GDP is strongly linearly related to the log of the newspapers per capita. Very strong positive relationship. Stable across time, stable across countries, everything. So all of your statistical information will tell you that this is a good relationship. So it means that if you want to increase growth rates for Pakistan, you should print more newspapers. Now, if you run a regression, this is what Barrow has done. I haven't done it myself, so I haven't confirmed it. That what Barrow found after studying 60 different variables, so he was doing something like encompassing, that the only strong stable relationship was the one between in GDP growth and a bunch of 60 other variables, was the one between education expenditure on education 10 years ago and current GDP. If you compare these two, the newspaper versus the education, statistically, the relationship for the newspaper is much stronger. So if you looked at the statistical grounds, you would prefer the newspaper relation. R squared is bigger, everything, the coefficient significance level is higher. The education GDP relationship is weaker, R squared is substantially lower, and similarly the significance coefficient is substantially lower. So on purely statistical grounds, you would say, okay, let's go with the newspapers. But anybody who has half a brain in his head will understand that the education is probably a causal relationship and the newspapers is not a causal relationship, or the causality runs in the wrong direction. Actually, what's likely to be true is that the development process is a multi-dimensional process which acts on one way. It increases your health, longevity, it increases newspapers, it increases GDP. All of these things happen simultaneously. So these two are correlated, but there is no causal relationship. It is neither true that if you increase the GDP, then the newspapers will increase, nor is it true that if you increase newspapers, GDP will increase. But actually, in the normal course of time, both tend to increase with each other without any causal relationship. On the other hand, the education GDP, Barrow maintains as causal, and he wants to make an argument. That's so, and it seems likely that there are, because you can trace a causal chain. I mean, if you provide education, more education, our people will have better skills, more human capital that directly contributes to their predictive capabilities. So one very important element of understanding causal relationship is the ability to trace the causal chain. That's called mechanism. This is extremely important and not mentioned in econometrics textbooks. So if you want to do real econometrics, you have to pay a lot of attention to mechanism. How things happen. What is the sequence? If I say that money growth will raise prices, a real econometrician will ask how. What happens? Who prints the money? Whose hand does it go to? Then what happens with this money? And how does it lead to? And it's not magic. You see, current econometrics is just magic. I sprinkle the money and magically the prices increase. No. You have to go to mechanism. How do the prices, how does increasing, what is it the state bank does? What happens at the next stage? What happens at the third stage? And finally, what happens? What leads to the raise of prices? So unless you know mechanism, you cannot understand causality. And econometrics is not equipped to answer questions about mechanism. Here's another graph similar here. We have quite a different situation. Oh, this is within a cluster, personal household goods. Here, interestingly, there are firms which have zero visibility clustered along one of the axes, and they are doing a lot of donations, and there is a group for which the visibility is positively correlated. So on the one hand, there is a cluster which confirms our basic idea that there is a positive relationship. On the other hand, there is a cluster which leads to a puzzle. These are firms which are contributing very much, but they are not very visible. I mean, the visibility factor is low. So again, this shows that visibility does not, for this cluster which is on the y-axis, this is the first time we have seen a cluster on the y-axis, visibility does not determine philanthropy, but philanthropy is highly variable even though visibility is zero. So now there are many questions that arise. First of all, there was this hypothesis that I had that if we do philanthropy, we will achieve visibility. This is shot down by this cluster at least. At least in this cluster, we have widely varying ranges of philanthropy, but zero visibility. So immediately we know that it can't be true in general. Maybe it's true in specific cases. And then we have this question that so these are firms which have a lot of ikhlas, sincerity, because they are doing charity without any visibility, without seeking any reputation. Again, this goes against a very strong theme in the corporate philanthropy literature, which says that basically you should do philanthropy only to achieve visibility. I mean, if you go into the standard Milton Friedman paradigm that the only thing which matters is profits, then basically you do philanthropy only to increase profits, and so you find that the profits will increase if you publicize your philanthropy. If you do it secretly, one hand doesn't know what the other is doing, then there will be no impact on profits, or at least one doesn't think so. So the literature is full of examples where the firm provides $1,000 worth of philanthropy and does $10,000 worth of publicity for this philanthropy. So now actually what Uzma found was that this was not true in Pakistan, which means that there are firms who are doing philanthropy sincerely according to the Islamic tradition. So that's a bit strange. I mean, one didn't expect to see this pattern in the data. So now, anyway, I will stop here and sum up instead of going through the other pictures. What I am saying here is that from the exploration, we are learning about the drivers, and we are learning what kind of a model would we want to make. So in the end, we might, so before we have done this exploration, we cannot understand anything about what the models are that we want to make. So basically, our baseline big model will be generated after, you see, as we go along, we keep generating hypotheses. Oh, this is true, oh, this is true, oh, this is true. And we keep writing down possibilities. I mean, this is just one cluster in one place that generates a certain type of hypothesis, and we keep going along and we generate. So this is exploratory data analysis. This is not confirmatory. As we have said, if I claim that from this picture that firm visibility causes CP, first of all, there is no causal relation, but even in terms of correlations, this is not clear, because actually the CP might be standing, the visibility might be standing in for some other variable. To give an example, there are many examples. A medical study showed that obesity was very strongly related to the probability of a heart attack. So the more a person weighs in excess of his normal weight, the more likely he is to have a heart attack. But then people did some more studies, and they looked at this variable which is called fitness. And fitness was measured by looking at and putting people on a treadmill and having them exercise, and then looking at heartbeat and how it changes. So now fitness was very closely related to obesity, but it was not the same thing. It was, I mean, you could find people who didn't have good fitness and they were having reasonable weight, and you could find people who were fit even though they were very overweight. They would walk a lot and so on. So once you put in, so now this is the interesting thing. If you do an encompassing analysis, if you put both fitness and obesity, then obesity disappears. It's not significant. So basically, heart attacks are caused by lack of fitness. But lack of fitness is very closely related to obesity. So if you don't do an encompassing analysis, you will automatically be deceived. And this happens all the time. So, but the hypothesis that we are looking at will be generated by this exploratory data analysis of the type that we have just gone through. हाँ, क्या हुआ? So exploratory and just generate analysis. These could be hypotheses. These could be shot down when we start looking at multiple variables. But when we look at interactions, we might find that what we originally conjectured was wrong. Just like if you look at the correlation, you will see obesity causes heart attacks because there's a strong correlation. But when you look at two variables at a time, then you will find, oh, I see, that was a misleading conclusion based on a missing variable on a partial analysis. But still, there's an explanation, you see. The false correlation is explained by a real correlation. So we have much more understanding of what is going on after we do the exploratory data analysis than just if we plunge into a multiple regression analysis without doing any looking at the data. Then we have no understanding. Okay, so I will stop here. Thank you. So